In previous classes we have discussed a lot much on the structures, what the user defined data type called as a structure is, in detail we have discussed. Now in this class we will speak about another user defined data structure called as a union. Okay. We will take up some of the sample programs using the unions, and then we will discuss how the structure and the union are related, what are the similarities between the two, how they are differ, what are their advantages and all. Yeah, this will be the learning outcome of the class. So, as I told, what the union is, how to declare a union, few sample programs we will see, and then similarities, differences between the two, some use cases where the unions and structures are being used along with the advantages. Now, the union is also another user defined data type which is similar to the structure in fact, but both of them differ in the way how the memory is allocated to these structure members. So, unlike the structures, in structure what happens is each of the structure member has its own memory location, whereas in the union all members will be sharing a single memory location, and usually to the member which needs a largest memory, that much memory will be allocated to that union. So, we will discuss, we will see one sample over here. So, this is the way how we define a structure, we know it. So, we are defining struct ABC to include int A and char B, right. So, and we know that integer is of type size usually of 4 bytes, and we assume 1 byte for B, a character. So, in how to declare a union, it is also similar to the struct only, right. So, except we use here as a keyword called struct, and this keyword is replaced by union. So, we define union ABC to include the same members A, B of type int and char in the same way. Of course, we need to add a semicolon here. Having this definition of a structure, I would like to know about the memory allocation of for these members, structure members as well as union members. As I have told already, if at all I would like to know the address or the memory location corresponding to member A and B, so this might be the value that I get on particular execution. So, A's address might be as a 588.642. So, if A, we know that A is a integer, and hence B's address will be, B will be pointing after 4 bytes, because A takes 4 byte size since it is a integer, and B takes of course 1 byte. So, 642 and this is 588.646, 4 bytes difference. Whereas, on the other hand, if I would like to see the address of AB with respect to union, right, as I told, union the memory will be allocated to the largest member of a union, and this seems to be larger over here because it is of size 1 byte and this is for 4 bytes. So, since they share the same location, memory location, see the address now. What would be the address? If A's address is this 588.642, then B's address also would be the same, not after 4 bytes, right. So, because of this feature they share same common memory location, right. And this is the memory allocation a diagram as an example. So, the struct ABC union ABC both are shown over here. So, this is a 1 byte word as an example. So, A is of 4 byte size since it is an integer, and B is 1 byte which takes the next address. Whereas, when I speak about union ABC, see that A takes 4 bytes, but B needs 1 byte which is shared from the ES location itself. Fine. So, in union now we can observe the fact that members will share same memory location, we understood it. So, because of that, if you make some changes to the values of any union member, then it will have an effect on the value of other member as well, because they share the common memory location. And hence, the size of union is taken according to the size of the largest member of the union. Whatever the number of members we have declared in the union, the particular member which needs largest memory, that will define a size of a union. This is another definition example. So, where we are defining a union to include integer value, float value and some pointer to a character. Okay. So, U is a union. In the same way, we define another user defined data type called as a union data to include int I, float f, character, string 20, array of characters. So, this is another union. We will see one program, simple program. So, the previous union whatever we have declared, that includes integer I, float f, character, I mean array of characters, string. Okay. This is a union. If this is a program where we are defining data small d of type union data. Okay. So, data is a user defined data type of type union data. So, we assign values to these variables. I takes 10, f takes some value 220.5 and str takes a value of C programming. So, this is the way how we assign a string to a character array. And if you print it, you can see what value do you expect as outcome of this, as output of this data I %d. I am printing a value of a, see I have assigned over here data of I, data dot f, data dot str we have assigned, and if I would like to print the statements, what do we expect as an output now, right? We print here data of I which is an integer value, data of f which happens to be a float value and then data str which happens to be a string of characters. So, this is the output, right. So, data I will not print this 10 or f will not hold this 220 value, because as this is defined, since they share the common memory location, So, it was there initially, but as you assign f value, this was overwritten, and as this value was written by data str, this 220.5 was overwritten by this, replaced by this value, and hence the presently available value is C programming, right. So, since all the three variables members are pointing to the same memory location, so some integer value of this C programming, actual value stored now is C programming, but since we are printing it, trying to print it, data I as an integer, corresponding integer value and some float value, right, and this is the actual value which is presently available in the memory location. Okay. Another example to include I, F, str same. Now, see the way how we assign and check the values. So, we have defined again the same data, user defined data type, which happens to be of type user union data. Again we assign the value of I 10 to the value of I, but we would like to print it here only to see whether it takes or not. So, on printing, definitely what will print now? This value will be printed, because currently I is pointing to the union's memory location, hence data of I will hold the value 10. In the same way, I can assign some value to the F, and if I print it to see what it holds, its present value now is 220, of course this will be output. In the same way, I assign this value to the string and see what is that. So, again so it is C programming only, right. So, it depends, then you can return and come out. So, it depends the way how we assign the values, or the way how we access the union members depends on us. So, simultaneously you cannot access the data members, you can access the data members one at a time, right. So, these are some of the observances, and having understood this approach, few more examples on the unions which may depict similar kind of approach or the discussion. Few more examples I have added here. So, it is a simple C program using structure and union to know the size of a structure and union. Already we have discussed, you must be clear now. So, here is one example that returns what would be the size of a structure and the union with respect to the definition whatever is given over here. So, I am defining union job, right, union job, which includes some variables members, name, salary, worker number, and we define a variable called u job to represent a union job type. Then another structure, this is a union and this is a structure called as a struct job, holding the same values, same members, name, salary, worker number, and I define a variable S job, U job, union job, S job, structure job. Now, I would like to see what would be the sizes of this structure and what will be the size of this union. Okay. So, printf size of union is equal to how many bytes. So, this is the built-in command, size of this is the structure union variable, size of u job. In the same way, what is the size of a structure? Size of a structure equals %d. So, we make use of a keyword size of this S job. So, what do you expect now? So, if you assume character takes 1 byte integer takes 4 bytes, float takes 4 bytes, double needs 8 bytes. With that assumption, what do we expect the size of the union and the structure to be in this case? See, the size of union is 32, right. So, as per our understanding, this takes 32 bytes and this is 4 bytes and this is another 4 bytes. As all we know, the largest member in this is this, because 32 bytes, 8 bytes, yeah, 4 bytes and this is 32 bytes. So, name is the member which takes the much memory among these variables, and hence 32 bytes will be allocated for this u job union. The size of union will be 32. But the size of structure, that would be sum of all these members, sizes of all these members, 32 plus 4 plus 4, 32 plus 4 plus 4. Okay. Another program, basic C program using union. Union job we create to include the members like salary, worker number. We define J as a union variable, fine. And now we start with the program by declaring the values or initializing the values. So, J dot salary is initialized to 12.3, as it is a float value, you can assign that value some value. Okay. But soon after this, if I assign the J dot worker number to 100, we know that this salary will no longer have its value available in that memory location, because it will be overlapped, overwritten on it. And if you happen to print now the values of salary and the worker number of workers, so what do you expect as output? So, see that currently the pointer, or it has a value associated with the worker number, and hence we have, since we have assigned 100, this is the actual value which can be accessed, but the integer the value related to the salary will be not printed actually over here. So, it means that we need to understand, by seeing all these things, we need to understand that unions of course are useful in particular scenarios. I will tell you that, but they cannot be used in all the situations. They are more beneficial whenever, even though there are multiple data types, whenever we need to access a particular data member at a particular time, at a given time, then in that situations union will be preferred. Okay. So, I will discuss it in the next slides. Another program to declare, initialize a union. I will be little fast. So, union pack, a character A, B, double C. So, here union object we declare a variable called P of type pack, because so here union pack is there. So, we assigned each of the members individually and would like to see the values P dot A. Since it is a character, I can assign this value and see what this would be. B, check out what the value will be, C, check out what the value will be, right. So, assign the value and display it. So, no problem, whatever the values we have defined, we will be able to see it, right. On the other hand, if you happen to see assign the values and access it together, P dot A, P dot B, P dot C. Okay. This is just another example which already we have seen already such cases. Okay. So, here occupied size by union pack will be 8 because A is a character 1 byte, B is a integer 4 bytes, C is a double which takes 8 bytes, and hence the size of a double C will be allocated as a size of a union. So, hence it is 8, and then individual values of variable A, B, C which were assigned as A 10 and this value, right, and then P dot A equal to A, P dot this assignment will lead to again some problem, because on assignment of the second value the first will be overwritten like that. Because of that, say A, B will represent some other value, not the actual values. Okay. So, with having discussed all these examples, sample programs, now let us see, let us observe how the union and structure are related, or is there any difference or how similarities between the two, and what are the other where exactly these structure and union are used. So, we see that similarities are both are the user defined data types, we know, right, and their members can be objects of any type. A particular structure can contain another structure, a structure can contain an array, and hence we say that the members can be objects of any other type, including structures or unions or arrays. So, both structures and unions support not all operations, they support particular operations, something like the assignment operator or maybe size of operator, that we have discussed in the previous classes. Okay. Provided the members, the number of members and their types be the same. Also, we have seen how the structure can be passed to the function as an argument, and we know the dot operator can be used with the structure as well as the union. Also, that pointer variable, I mean arrow operator also can be used along with structures and unions to access particular members of the structure or the union. So, mostly they are similar in much of the aspects in accessing and all, but when there are differences also when it comes to the memory allocation for the structure as well as the union. So, some of the differences that now we can see how the structure and union are differed together in particular aspects. So, these are some of the aspects that we consider, through which we try to differentiate the structure and union. So, keyword used for the structure is start and keyword used with the union is union. And with respect to the size, you know, each of the member gets a separate memory location with respect to a structure, and hence the size of a structure will be the sum of sizes of its all members. Whereas, in the union, since the memory location is shared among all the members of a union, the size of the union will be representing the size of the largest member. equal to the size of largest member. Similarly, memory. So, each member within a structure is assigned a unique storage area of location, right, whereas memory allocated to the union is shared by individual members of the union. Then value altering. So, since each of the member is allocated with a different memory location, if you alter the value of a one member in the structure, it will not have an impact, or it will that change will not affect the value of other variable. Whereas, with respect to union, if you alter the value of one union member, that will have an effect on the value of the other member. In the same way, how to access the members, right? So, all the members can be accessed at a time, multiple members can be accessed, whereas only one member can be accessed at a given time with respect to union. So, having seen some similarities and the differences between the two, so lot many uses or real world examples we find, right, where these have an impact actually, right, maybe database management systems, graphics programming, device drivers, file systems, networking and protocol handling, embedded systems, like this they are used in many scenarios. So, just as an example, how the structure or the union can be used in the database management system. We know the DBMS, what the database is. So, database happens to be a collection of some records, a table of some records, right. So, we used to create a particular schema for a table, and then we enter the values of the attributes of that table, values to the attributes of that table usually, right. So, now structure can be used to represent the values for, or it can be used to write schema for the table. So, structures are used to define the schema of tables where each structure represents a row or record. Got it? So, in the same way, if we speak about a union, union might be used when dealing with different data types, of course, we have discussed it, stored within a single field, right. But in a particular scenarios wherein a single variable or the attribute can be accessed at a given time. As an example, one application or one usage scenario I can tell is payment methods in a financial database. So, when you are purchasing something, maybe through the Flipkart or Amazon, so you have added it to your cart and you are asked to make a payment. Then you are given with some choices. It may be UPI, or maybe net banking, or maybe debit card, credit card, lot many options are there for the payment, right. So, you may wish to consider any of these payment method, either the UPI or net banking or anything, right. But see that if you choose UPI, then only the form related to collection of a data associated with your UPI will be asked. You are asked to enter your UPI ID and go ahead with payment. Or if you have selected net banking, then you are asked to enter your user ID, password, so that you can log into your account and proceed further for the payment. Or if you have selected maybe the credit card or the debit card, then you are asked something else, what is the ID associated with the card, what is the validity of the card, expiry date of the card, what is the CVV, like all these information, depending on what you select, accordingly you will get, or you are asked to enter. So, this is the way how structure and union can be used in the database management systems as an example. In the same way, lot many areas, graphics programming and device drivers, where structure are commonly used in the device drivers to represent hardware registers or the control structures, and also unions might be utilized for representing different data representations for the hardware. In the same way, file systems, you know, right. So, file directories, files are there. So, when the file is created, who has created it, what is the size of a file. So, these are some of the attributes associated with each of the file or a directory, right. So, structures can be used to hold or represent such information. We call it usually as a metadata. To hold a metadata associated with the files, structures can be used. In the same way, union can be used to differentiate different types of the files within the directory. And another case is it can be used in networking and protocol handling, right, where we come across lot many protocols in the communication network or computer networks, IPv4 protocol, IPv6 protocol, many more. So, here in the network programming, structures can be used to define headers for various protocols, right. So, each of the header of a protocol will have its own structure, fine. So, structures can be used in such situations to organize and process the data in a proper manner. Similarly, the unions also can be used for interpreting different parts of a network packet depending on its type, what type of the packet it is, whether it is a data packet or a control packet or what else. In the same way, we see embedded systems and many other areas. And now we speak about some of the advantages. So, with this discussion, I am sure that you must have observed what are the importance of the structures and unions. So, here I have listed out some of the advantages of the structures, where it is useful for organizing the data, right. So, in the sense, different types of the data are grouped together under a single name to represent a particular entity. Maybe as an example, employee information, something like name, ID, salary, date of birth, mobile number, email, everything can be added into a single structure. So, in the same way, to have a modular approach for simple and beautiful representation of a particular program, it helps a lot as it encapsulates related data under a single unit. So, modularity can be achieved, and abstraction. So, it abstracts the complex data relationships by representing them in a simple and logical manner, which enhances the code comprehension. So, passing complex data to functions. So, structures can be passed as an argument to the functions. So, these are some of the advantages of a structures. In the same way, here are the advantages of the unions, where it is memory efficient, flexible data handling, size optimization. So, already we have seen that unions allow multiple variables to share same memory location, it saves lot much of the memory. So, and hence memory efficient. So, flexible data handling is possible, and since it is memory efficient, we know that size optimization. So, we come across in certain situations where we expect criticality, or we are restricted with the memory usage, right. So, where we speak about the applications which are memory constrained, right, where memory happens to be a critical. In that situation, union become very much essential as they save the memory. Since the members in the union share the memory locations, it will help into optimizing the size of an application, right. So, this is how we have discussed what the union is, what is the syntax, some of the sample programs we have discussed, followed by what are the similarities and the differences among these structures and the unions. Also, we discuss some of the real world use cases. Thank you.